Unit 4, Section 13.4, Worked Examples. Determine a spanning tree for the graph below. A spanning tree is a connected graph in which each edge is a bridge. So what we want to do is remove edges while still maintaining a path, a connected graph. And if we look at some of the examples here, we can eliminate B because B is not a connected graph. If you notice, it's not connected. There's not a path between every pair of vertices. Same thing with C. C is also not a connected graph. So we have a choice between A and B. And if I notice in A, I could still remove some edges there while still maintaining a connected graph. So the correct answer for this is going to be D. I still have a connected graph and every edge is a bridge. Use a tree to show the employee relationships in the Allied Auto Parts Company. President Richards has two vice presidents, Greenberg and Marley, and I notice in all of the graphs that are presented, it does show Richards with, except for D. A, B, and C all show the President Richards with two people reporting to him. We can eliminate D because D only shows Marley reporting to the president. Greenberg's in charge of three regional managers, Reynolds, Hahn, and Johnson. Reynolds, Hahn, and Johnson. And if I look at graph C, that doesn't show all of those three people reporting to Greenberg, so we can eliminate C. Marley's in charge of two regional managers, Croft and Smith has an assistant. If I look at graph A, the assistant Lowell here is showing as reporting to Marley, which is not correct. The assistant reports to Smith, so the correct graph is B. The Blue Ridge Electric Cooperative in western North Carolina wishes to connect cities in the area with new, more efficient electrical power lines. The cities include Asheville, Blowing Rock, Boone, Little Switzerland, and West Jefferson. The distances in miles between the cities involved are given in the following graph. Represent the information in a weighted complete graph. So I went ahead, there's 5 cities, Asheville, Blow Rock, Boone, Little Switzerland, and Jefferson, and I went ahead and put those 5 cities down as the vertices. And then I created the graph showing the linkages between the cities and also the weights assigned to those distances. And there's my complete weighted graph there. Now, what we want to do next is to use Kruskal's algorithm to find a minimum cost spanning tree that would link each city to create the least expensive power line network. Remember Kruskal's algorithm. To construct the minimum cost spanning tree from the weighted graph, select the lowest cost edge on the graph, then select the next lowest cost edge that does not form a circle with the first edge, and continue in the same sequence until all the vertices have been connected. And when you're complete of this, you'll have the minimum cost spanning tree. So here's the original weighted graph. And if we notice, the shortest distance here is 5 between Blowing Rock and Boone. So we're going to keep that. And then the next shortest distance is 18, which is between Boone and West Jefferson. The next shortest distance would be between Blowing Rock and West Jefferson, but that would create a circuit right here. If I notice right here, that would create a circuit, and I don't want to do that, so I'm not going to include that portion because that would not accomplish what I want to do. So I'm going to skip that one and go to the next shortest distance, which would be right here, which is Blowing Rock to Little West Switzerland. And then the only thing now I need to include is Asheville because I've got the others connected together. And so I'm going to go from Little, and the shortest way to get Asheville from the cities I've already concluded is to go in this direction here. And so here is my minimum cost spanning tree. And the distance that's involved here is going to be 35. Let me get my calculator. And I'm going to add those distances up to find the distance of that path. So it's 35 plus 26 plus 5 plus 18, or 84 miles. And I'm going to put that down here. And then they want me to figure out the actual cost because they told me that the cost per mile for the electrical power lines is 2,700 miles. So I'm going to take 2,700 times the miles, which I still have in my calculator, to find the total cost of establishing this minimum cost spanning tree. It's going to be $226,800. So 226,800.